So now let's see some basic concepts of summation like AP, GP, HP, AP, GP, AGP. You have already seen these, yes or no? In the fundamental course, all these concepts have been taught, correct? AP has been taught, GP has been taught, AGP has been taught. These concepts, yes or no? Do you remember these concepts? Like AP, this is the series AP, arithmetic progression. In the foundation course, we have already seen this. Okay, so this is the AP series, arithmetic progression. In the arithmetic progression, what we do? Basically there is a common difference. There is a common difference. Like for example, this is the first term. Now this is A plus D. Now this D is the common difference. So the next term will be A plus 2D. The next term will be A plus 3D, like this. Okay, so you can find the nth term. The nth term will be A plus n minus 1D. And the summation of this series, that will be 1 by 2 n first term plus last term. Okay, so this will be the summation of AP. So remember, if you have this AP, let me just give you the final. If you have an AP like this is the first term. This is your first term. Okay, and let's assume common difference is D. Then this is your second term. This is your second term. So this will be A plus 2D. Then you will have A plus 3D. So tell me, what is nth term? Can anyone tell me what is nth term? In the second term, you have 1. In the third term, you have 2. In the fourth term, you have 3. So in the nth term, you will have n minus 1. In the nth term, you will have n minus 1. This will be the AP. And what is the summation of this AP? Like if I ask you, this is your series, let's call it series S. So if I ask you, what is the summation of this series S? If you add all of them, then that will be half n multiplied by first term plus last term. First term plus last term. Let me call it last term. So this will be first term plus last term. Okay, this will be the summation of AP. Is this clear? If you add all these things, then you will get this summation. You can also study like this GP. In this GP, we have a common ratio. In this GP, what we have? In this GP, in this geometric progression, we have a first term. Then there is a common ratio, like we multiply with R. Then we again multiply with R. Then we again multiply with R, and so on. So if this is your first term, this is your second term, this is your second term, this is your third term, then what is the nth term? What is the nth term? Remember, in the third term we have 2. In the second term we have 1. In the fourth term we have 3. So what will be the nth term? That will be A into R power n minus 1. In the fourth term we have 3. So we will have A into R power n minus 1. This will be the nth term. And what will be the summation of this GP? If you do the summation of this GP, then what that will be? That will be first term A into this common ratio A into R, number of terms is n, A into R power n minus 1 upon R minus 1. This will be the summation. Okay, tell me this, let me ask you this question. I am giving you a series AR square and so on, AR power n. Then tell me what is the series, what is the summation of this? What is the summation of this? Tell me what that will be. This is the series AR square, A power n. What will be the summation? So is this correct? Is this correct? Just tell me this point. Is this correct? This is not correct. This is not correct, because how many terms we have? Number of terms. How many terms we have? We have n plus 1 terms we have here, because it is starting from 0. It is starting from 0. From 0 to n. From 0 to n, we have n plus 1 terms. Total n plus 1 terms we have. So the formula will be A into R power n plus 1 minus 1 divided by R minus 1. So remember, the formula is like this. The summation of GP formula is like this. So take care about this. Summation of GP formula is like this. First term. Okay, the summation of this is like this. First term multiplied by common ratio power number of terms minus 1 divided by R minus 1. So here you have number of terms, and this is your first term. So in this sequence, you can notice this is very common mistake. that whenever people see this AR power n, then they directly, because this is the by-hearted formula, so they just answer this. But actually you should take care. We have n plus 1 terms here. So this will be correct. This is your GP. Now we have something called infinite GP. If you have an infinite GP, if your GP is infinite, for example, A, then you have AR, then you have AR square and so on, infinite. This is the infinite GP. Then what is the summation of this? What is the summation of this GP? That will be first term. Remember the formula is like this. First term divided by 1 minus common ratio. So remember the formula is first term. You always start. So first term divided by 1 minus common ratio. This will be the infinite GP formula. A into A upon, A upon 1 minus R. Next is arithmetic AGP. Next series is AGP. In this series, what we have? In this series, we have AP also, GP also. So this is your AGP series. In this series, we have AP, GP. For example, let me give you a sequence like this. A, then you have A plus D. So you have A plus DR. Then you have A plus 2D R square. Then you have A plus 3D R cube and so on. This is your AGP series. Let's assume this is your infinite AGP series. Now you can notice this is the AP. What is going on here? This yellow. If you see this yellow color is your AP series. And if you notice this blue color is what? This blue color is your, this is your GP series. So the combination of these, that is called AGP series. So this is your AGP series. AP and GP combination. We have a combination of AP and GP. You can notice yellow color is AP series and this blue color is basically GP series. This is the combination of AGP series. Now, do you know how to solve AGP series? Do you know? For example, if I give you a AGP series, like this type of series, if I give you, this is the series. I want to find the summation of AGP series, means A plus DR plus A plus 2D R square plus A plus 3D R cube plus and so on. So how to find this? This is infinite. This is infinite. Then how to find this? Multiply with R. So this is the procedure. The procedure is very simple. You multiply with R. So okay, multiply with R and write like this: AR plus A plus DR square, A plus 2DR cube. So basically multiply with R, multiply with the common ratio, and then you shift it. Now what you do? Now you minus, now you subtract S minus RS. What that will be? That will be A plus, okay, if you subtract this, from this if you subtract this, then you will get DR. From this if you subtract this, then what you will get? You will get DR square, then you will get DR cube and so on. This is infinite. So tell me what you will get? That will be A plus, look at this. This is your infinite GP. This is your infinite GP. So what is that? That is DR divided by 1 minus R, because this is your infinite GP now. And we know the formula for infinite GP. Now from here, what we will get? S. We want S. S will be A upon 1 minus R plus DR upon 1 minus R whole square. And this formula we will remember, because in the generative function, this infinite AGP series is very important. Remember, in generative functions, the most important thing, okay, this infinite AGP is most important, very important. So we don't want to calculate it again and again. This infinite GP formula, this infinite AGP formula, we will remember. Okay, this infinite AGP formula. So what is the infinite AGP summation formula? This we will remember. The proof is this. The proof you have seen. This is the proof. And the formula we will remember. So summation of infinite AGP, that will be equal to first term divided by 1 minus common ratio plus D into R, that is divided by 1 minus R square. What is this D here? This is the AP difference. This is the AP series difference. This is the AP difference. And this is your common ratio. And this is your first term. So we will remember this formula, because this formula we will use again and again. Is this clear to everyone? Tell me. So the first term divided by 1 minus r, this is normal infinite, this is your normal infinite GP, plus d, this is d, d is the common difference, this is the difference, sorry, this is the difference of AP, dr divided by 1 minus r whole square. Okay, very simple. So all these are the basic concepts. Now let's move on. So tell me, what is the generative function for this sequence? I am giving you a sequence, and the sequence is like this: AK. Okay, this is the sequence where k is greater than or equal to 0, and AK is given to you as 3. So what will be the generative function for this sequence? The question I am asking is generative function, means I am asking AK multiplied by x power k. Yes or no? I can ask you like this: what is this? Can anyone tell me what is this? Can anyone tell me what is this? What is this? AK multiplied by x power k. K is going from 0 to infinity. K is going from 0 to infinity. What is this? This is the generative function, right? This is the generative function for this sequence. For this sequence, this is the generative function. So tell me what will be the answer? AK is equal to 3. So tell me the answer. It means AK is equal to 3. K is greater than equal to 0. It means every term is, so what is your sequence? Your sequence is like this: 3, 3, 3, 3, and so on. This is your sequence. So what will be the generative function for this sequence? That will be 3 into x power 0. So it will be 3 in, okay, so I can say this will be summation of 3 into x power I, okay, where I is going from 0 to infinity. So that will be 3 multiplied by, okay, so that will be 3 multiplied by 1 upon 1 minus x. 3 upon 1 minus x. This will be your answer. 3 upon 1 minus x. Because this is your sequence. For this sequence, you can find the generative function. The generative function will be like this: 3 plus 3x square plus 3x cube plus and so on. This is your infinite GP. This is your infinite GP. And for infinite GP, the formula is first term divided by 1 minus common ratio. This sequence is given to you: AK, where k is 0, 1, 2, k is greater than or equal to 0. So your sequence is AK, where k is like this, and AK is given to you as 3. What this means? This means that your sequence is, remember, k is going from 0, 0, 1, and so on. So your sequence is like this: A0, A1, A2, A3, like this your sequence is. And AK is equal to 3 for all k. AK is equal to 3 for all k. So it means this is also 3, this is also 3, this is also 3, this is also 3. So this is your sequence. Is this clear? Similarly, I can also give you like AK equal to k plus 1. Then what will you do? If I give you AK equal to k plus 1, I give you a sequence. I give you a sequence which is AK, and where k is greater than or equal to 0, and this AK is given as k plus 1. Then what will be the sequence and what will be the generative function? So the sequence will be what? The sequence will be, remember, k is greater than equal to 0. So your sequence is basically like A0, A1, A2. This is your sequence. And what is A0? AK is equal to k plus 1. So A0 is 1. This is 2. This is 3. This is 4, and so on. So your sequence is like this. Now, what will be the generative function for this sequence? That will be 1 into x power 0 plus 2x plus 3x square plus 4x cube and so on. Which series is this? Can anyone tell me which series we have? This series, what is this series? This is your infinite AGP. This is your infinite AGP series. So generative function for this sequence, that will be 1 plus 2x plus 3x square plus 4x cube and so on. So the generative function, this is your infinite AGP series. So the answer will be A upon 1 minus R. Okay, the common ratio is x, because you can notice this is your GP, this is your GP, and this is your AP, this is your AP, this is your AP. So finally I can say plus D. D is equal to what? D is equal to 1. 1 multiplied by dr divided by 1 minus x whole square. So the answer will be this. So your generative function is what? Your generative function is 1 upon 1 minus x plus x upon 1 minus x whole square. They can also give like this, 1 upon 1 minus x whole square. So you can take it LCM. This you can take it LCM. Then you will get 1 minus x plus x. So what that will be? So if you take it LCM, then what that will be? That will be 1 upon 1 minus x whole square. So this is your final answer. So they can give you this option or they can give you this option. They can give you any option. Is this clear? Tell me. Let me know. So what is the generative function for this sequence? For this sequence, the generative function, is this finite sequence or infinite? This sequence is a finite or infinite sequence? This is a finite sequence. So the remaining are 0, 0, 0, 0. So the generative function will be this. So you can notice this will be the generative function. Yes or no? They can also tell me this is a GP, not infinite, but this is a GP, right? This is your GP. This is a GP. So what I can say, this formula will be A into R power n. How many terms we have? Number of terms is 6. R power n minus 1 upon R minus 1. So they can give you this also. So this is the idea. Okay, very simple. Now remember one more thing. We don't care about convergence. This convergence thing we don't care about because we are not interested in value of x. We never put the value of x. Okay, so that is the idea. Now let's move on. So now you can simply see these generative function, you can check it out. Okay, so for these series, these will be the generative function you can very easily check out. For example, if your sequence is this, if your sequence is 1 minus 1, 1 minus 1, then your generative function will be this. And this series, this is your infinite GP. This is your infinite GP where common ratio is where common ratio. What is the common ratio here? Common ratio is minus x. Common ratio is minus x, not minus 1. Common ratio is minus x. So this will be the generative function. Okay, so very easy. Now let's move on. Now let's see that for the generative function you can do differentiation also. For the generative function you can do differentiation also, because remember generative function is a function. This generative function I told you, this is a function. Ultimately this is a function, and so for this you can do the differentiation. You can find the differentiation on both sides. You can differentiate. So let's understand the differentiation concepts. Before we study this concept, let's see some differentiation. You will study this in calculation, but let's see the basic differentiation concept. So can anyone, okay, like in your school life you have seen this, what is differentiation? This is your d dx. This is your d dx of some fx. We also write it f dash x. This is how we write f dash x. This is the differentiation. So for example, this is a very famous, like your favorite. What is the differentiation of x power n? This is your favorite. d dx of x power n. What is that? That is n into x power n minus 1. This is the favorite, right? So the differentiation of x power n, that is n into x power n minus 1. Okay, tell me what is the differentiation of f plus g. If you want to find differentiation of f plus g, then that will be what? That will be differentiation of f plus differentiation of g. Yes or no? You can do this. So this is the idea. Now let's see what is the differentiation. d dx of 1 by x. What is that? What is that? d dx of 1 by x. What that will be? No, that is not log. I know many people will say log. That is not log. See, this is d dx of x power minus 1. This is 1 by x. So this is d dx of x power minus 1. Now x power n, okay, the differentiation will be n into x power minus 1. So that will be minus 1 multiplied by x power minus 2. So this will be minus 1 upon x square. Is it clear? So remember d dx of, so if you have this 1 by x, its differentiation will be, if you do the differentiation d dx of 1 by x, then for this you will get minus 1 upon x square. This is what you will get. Okay, so this is the concept of differentiation. These differentiations we use, these are very simple. And what is differentiation of a constant? What is ddx of a constant? If you have a constant term, then that is 0. That is 0. Okay, next. So this is the idea. Now let's move on. And remember ddx of, what is ddx of, for example, a into x power n, like a into fx. What is that? ddx of a into fx, that is a, you can take it out and then you can find f dash x. Okay, you can take out a, this constant you can take it out and then you can find f dash x. So this is the concept of differentiation. We will study differentiation in the calculus. Now let's see that you can do differentiation in generative function. For any generative function you can do the differentiation. If you have a, for example, if you have a sequence, this is your sequence a0, a1, a2, a3, a4 and so on. So what is the generative function? The generative function for this sequence, that will be a0. Remember, I can say generative function for this sequence, I can write it as gx because this is in terms of x. So the generative function will be like this: a0 x power 0 plus a1 x plus a2 x square plus a3 x power 3 and so on, plus an x power n and so on. Okay, so this will be. Now you can do the differentiation on both sides. So tell me, what will be the differentiation here? That will be g dash x. This will be the differentiation of this g dash x. And what will be differentiation of this? That will be 0. This will be 0. This will be what? This will be a1. This will be 2a2x. This will be 3a3x square. Then it will be 4a4x cube and so on. So this is your g dash x if you do the differentiation. Now remember, this new generative function that you got, for this, what will be the sequence? Tell me the sequence. This new generative function that you got, for this, what is the sequence? The sequence is, what is the sequence for this? The sequence will be a1. This is the constant term now. This will be a1, 2a2, 3a3, 3a3, 4a4, 5a5 and so on. This will be the, yes or no, this will be the sequence. Agree? Did you understand this? You have a sequence. For this sequence you can find generative function. From that generative function you can do differentiation. This differentiation you can do, and from that differentiation you can find another sequence. So this sequence you will get. So this is the idea. If you have a generative function for this sequence, remember, if you have a generative function, for this sequence, this generative function you have for this sequence a0, a1, a2, a3. For this sequence you have this generative function. Then what will be the sequence for the g dash x? For the g dash x, what will be the sequence? That will be a1, 2a2, 3a3, 4a4, like this. Okay, so like this, an, like this. So this is the idea. So let's take example. For example, you know that this is your generative function. Now when you do the differentiation, what will you get? Do the differentiation. Tell me, what will you get if you do the differentiation of this? Remember, I told you that this will be the differentiation of 1 by x is minus 1 upon x square. So this will be minus 1 upon 1 minus x square. Then you do the differentiation of 1 minus x. Then you do the differentiation of 1 minus x. So that will be minus 1. Okay, it is like this. So let me just tell you that this is your 1 upon 1 minus x. If you want to do the differentiation, then that will be what? That is very simple. So it will be like this. First you do, remember, ddx of 1 upon x, that is minus 1 upon x square. So similarly, this will be minus 1 upon 1 minus x whole square. Then you do the differentiation of this. Then the differentiation of this will be 1 minus x. The differentiation will be like this. So finally, you will get 1 upon 1 minus x whole square. Okay, finally it is like this. So this is like a chain rule. you will study in the calculus. You don't have to worry about it. Okay, you will study this in the calculus subject. So this is like a chain rule. Okay, it's like this. So if you want the ddx of 1 upon fx, then that what you can do, you can basically do like this, that first you can do minus 1 upon fx whole square, minus 1 upon fx whole square, and then you can do f dash x. So something like this. So if you have 1 upon fx, then how will you do? Minus 1 upon fx whole square, and then you can do f dash x. So this is what we are doing. First we are doing this. First we are doing this minus 1 upon 1 minus x square, like this. For example, similar to this. Then we are doing the differentiation of 1 minus x. This is the differentiation of 1 minus x. So like this f dash x. So this is what we are doing. So if you do the differentiation, then you will get this statement. This you will get means 1 upon 1 minus x whole square. This is what you will get. And from this what you will get? From this what you will get? You will get 1 plus 2x plus 3x square plus and so on. So tell me, this generative function is for which sequence? This generative function is for which sequence? This generative function is for which sequence? Tell me. This is the generative function for this sequence. So using the differentiation, you can find generative function for another sequence. Is this clear? Is this point clear what I'm saying? Using the differentiation, if you do the differentiation, then you can find generative function for another sequence. So if you want to find, if you have a generative function for this sequence, a0, a1, a2, a3, for this sequence, if your generating function is g, then you can find generative function for this sequence, a1, 2a2, 3a3, 4a4, and so on. For this sequence, the generative function will be g dash x. So this is the statement. So you can find using differentiation. If you already have generative function for this is the generative function for this sequence, then for this sequence, generative function will be g dash x. For this sequence, a1, 2a2, 3a3, 4a4, like this. Okay. So this is the idea. So you can check it here. Okay, you can check it out. If you do the differentiation, if you keep doing the differentiation, new sequences you will get. This is the generative function for this sequence. Okay, now if you do the differentiation, then you will get generative function for this sequence. If you again do the differentiation, you will get the generative function for this sequence. If you again do the differentiation, you will get the generative function for this sequence. Again do the differentiation, generative function for this sequence. Okay, so like this you can keep getting. But in the GATE exam, you don't have to do like this. In the GATE exam, if I ask you what is the generative function for this, then how will you find out? In the GATE exam, if I ask you, so let me ask, for example, this is the question I ask you, that this is your 0, 1, 2, 3, 4. Then what will be the generative function? Then you will do the AGP. Yes. If I give you this sequence and if I ask you what is the generative function, then you will find the AGP. You don't do the differentiation. This differentiation you don't have to do in the GATE exam. I am just telling you that you can do differentiation. In the GATE exam, you don't have to do differentiation. Don't do differentiation in the GATE exam. Don't do that. Okay. But I am just saying that if you have this question in the GATE exam, then your answer will be what? Then very simple, just make the series. So the series will be like this: 1 into x plus 2 into x square plus 3 into x cube plus 4 into x power 4, and so on. So what will be this is your AGP. This is your infinite AGP. We got this gx as like this, we got this gx. Now this is a AGP series. Now what will you do in this AGP series? Then you can multiply with the x. So you will multiply with x. Then you will shift. So you will get x square plus 2x cube plus 3x power 4, and so on. You will shift it. Then what will you do? Then you will subtract. So g minus xg, that is equal to x plus x square plus x cube plus x power 4, and so on. Now this is your infinite GP. This is your infinite GP. So I can say that will be x upon 1 minus x. So from here, g will be equal to 1 upon 1 minus x. So you will get x upon 1 minus x whole square. Okay, so this is the idea. Very simple. So you multiply with the common ratio. The common ratio is x. You multiply with x, then you shift, and then you subtract. So this is what we will get. So g equal to this.